Oxygen Blast technical seminars are an Intertech production. For instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.
So JAX-RS is our specification, is our Java specification for how to build RESTful web services today. Yep, you can use some other technologies, but most people are finding a JAX-RS specification to really help tidy up things and not require us as developers to be burdened with all the marshaling and unmarshaling of data and routing and traffic, things of that nature. But as with all specifications in the Java community, JAX-RS being just a specification, you need an implementation. What is the implementation for us in the Java community? Well, there's the Jersey project, an open source project which has become some Sun's reference implementation of this specification. So Jersey is the implementation, one of many that you can use to provide JAX-RS in your environment. Again, it is a reference implementation, and as such, it's also part of the Glassfish project. For those not familiar with Glassfish, that's, again, the Sun's, if you will, reference implementation of the Java enterprise environment, providing us a nice application server environment for running all of the Java EE APIs, and in some cases even using that in the production settings. So Jersey is not only the reference implementation, but as the leading implementation, at least today in the Java community, it's also made part today of the Java Enterprise 6 environment. That's a relatively recent release as well. Java Enterprise 6 came out just at the latter part of 2009, and it started to be adopted here in 2010 by many organizations, and certainly will be part of your environment at some point in the near future. As I mentioned, JAX-RS is specification to which Jersey is an implementation. However, it's not the only implementation. So if you're not a fan of using the reference implementations, you want to go out there and find another implementation, you'll find a few, not a ton of them out there yet today. But one that you might find, if you're certainly in the JBoss community, one that probably will be of interest to you is the REST Easy project, which is JBoss's implementation of the JAX-RS specification. So how do we get Jersey, and how do we get it set up in our environment so we can start to play around with it and start to use it to satisfy our web services needs? It's not part of the Java runtime environments that we'll see, at least in most circumstances today. In fact, again, as it's just being added to the Java Enterprise 6 environment, and most of us don't have Java Enterprise 6 yet, what you're going to need to do is download an implementation, in this case, download Jersey at the jersey.dev Java net site. That's going to include the Jersey libraries, everything you need to run Jersey, along with a few other things. You'll find that it includes something called the core server. You can actually find that it will provide a kind of a low-level testing server runtime environment, and a Jersey client, something we'll address as part of the end of our discussion here today, which is not driven by specification, but provides some conveniences for those who are looking to build RESTful clients. And it also includes a number of the jar files to help get it up and running. In other words, you're going to find, as with most open source projects today, it's dependent on a lot of third-party jar files, to include something called the ASM jar, a bytecode manipulation framework, and a JSON jar, which really is what provides the JSON formatting needs if you choose to offer JSON format through your RESTful web services. So those dependent jar files, also something you want to grab when you go to the Jersey download, as you want to put all those and make all those a part of your project and available on your class path. With Jersey added to your project, what's next? Well, the next thing we have to do is inform our application environment that we're about to use Jersey, or that, if you will, traffic needs to be routed to our Jersey environment. Now, what Jersey provides at its heart is something called the adapter servlet. Think about it, all this, you've got a client out there, and a client is sending in all these RESTful requests via URL out to our server. How does the Jersey environment, if you will, intercept those requests and get those routed to the appropriate POJO, which will be one of those resource request providers that we'll talk about? Well, and to do that, we need to essentially tell our server environment that this traffic is coming, and we need something in place that intercepts that traffic and routes it appropriately to our plain old Java objects, our Java beans. That's done via a servlet in the Jersey world. This adapter servlet then has to be provided in our web XML file, just like any other servlet, to inform our application container that we've got this servlet in place that should be receiving traffic, and then that traffic needs to be routed appropriately. Inside of your web XML file then, what you're going to want to do is add a servlet element that looks something like what we see here. Our Jersey adapter servlet has to be specified via this servlet class, the servlet container class, provided in that Jersey jar file. In addition to the servlet element, you're going to need a mapping element. Now, the mapping element is critical to determine what traffic, what URLs are going to get routed to that servlet. How do we set that up, and what do we specify there? We'll use the same servlet name, in this case, per my previous slide, Jersey adapter servlet, and then the URL pattern has to specify which traffic is going to be routed into this adapter servlet, just like any servlet. And it's pretty typical, at least developers inside of the Java JAX-RS environment, to use this /resources / pattern that allows all incoming traffic for /resources to be routed appropriately to a RESTful resource. Now, this is of your choosing. You can certainly specify any pattern that you'd like. Obviously, take into account that if you've got other pieces in your application environment that you want to route traffic to, you want to make sure to avoid any kind of conflicts with those other resources, other servlets or JSPs or what have you. So /resources / is what's going to be used throughout the rest of this demo, but choose your pattern as you need. Now, in addition to the servlet element and the servlet mapping element, an additional init parameter has to be specified to provide Jersey an indication of what RESTful web services you have out there. But before we get into those details, we need to know a little bit more about the RESTful web service API and how things are done in JAX-RS. We'll come back to that last init parameter that has to be inside of your web XML after we get done talking about how to construct a RESTful web service and how to invoke it. So now let's get into that idea of constructing a resource, or if you will, something that responds for a request for state in our RESTful web service world in Java. Using a JAX-RS, again, REST resources are just plain old Java objects. Or I guess we could say also Java beans, the more specific type of plain old Java object, if you will. We take those plain old Java objects and we annotate those with an @path annotation. Yep, folks, JAX-RS is heavily annotation-based. So if you're of the type that prefers not to use annotations, or if you have restrictions against using annotations, well, you might take a look at the specification, take a look at the API, and see if there's some negotiation room for you and your environment there. This is one of those things that's kind of part of the JAX-RS environment. If you don't like annotations at this point, you're kind of left wanting. So we take a POJO and we put an @path annotation on it. And that @path annotation takes one argument. And what's in that argument? Well, this identifies the relative URI path for which this resource will respond. So in this case, the hello world resource that I have here is going to respond to something /hello world. Now you might say, well, what's the rest of the path? Well, again, that's going to be based on your domain, things like your port numbers, your application context. In most cases, we're going to be running this in something like a web container, as I will be showing you some demos here in Tomcat. So however you would normally get to a resource in that particular web container, all has to be provided as part of that URL. The path that we see here is everything after how to get to that particular web application. Now, like all annotations are part of our language, part of our environment today. And so as part of that path, we need to do an import in this class, which is not shown. So in this particular case, we'd also have to do an import of the java-xws.rs package to get this, as well as a number of the other annotations that we'll see coming up in just a bit. So in our particular case, that path, as I mentioned, relative path. So what is the full path going to look like? Again, take into account your server, your port, your application context, your Jersey servlet mapping. So in my case, I put there /resource. And then we'd see our path, in this case, /hello world. So here's an example of how to communicate with my particular hello world resource, my particular hello world POJO. Nice thing about the way that the JAX-RS API has been developed, paths are automatically encoded. So whether or not you have the @path hello space world, that will be the same as if we put the encoding %20 in there for those who are web/HTTP world aware. Those are going to act and behave the same. So that's all taken care of for us. And oh, by the way, we can also use things like wildcards, the asterisk characters, and even regular expressions to help assist in the mapping through that web XML file and or through our actual app path annotation.
For more free learning resources and to see the latest lineup of our instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.